What the study says.
Imagine this, a fish, completely still, not moving a single fin, okay? And yet somehow it's swimming upstream.
Mm-hmm.
Sounds like a riddle, maybe? Or, something impossible. Well, today we're taking a deep dive into a piece of science that sounds totally made up, but believe me, it's very real.
And pretty mind-bending.
Welcome back to What the Study Says. I'm Dr. Kai.
And I'm Dr. May.
And yeah, we're diving into the often hilarious but always thought-provoking world of the IG Nobel Prize.
Right, the prize for science that first makes you laugh and then makes you think.
Exactly. And our focus today is last year's, the 2024 IG Nobel Physics Prize winner. It's a study on something called passive propulsion in vortex wakes.
And what's really amazing here is just how counterintuitive it all is. The core discovery, I mean.
Totally. So what did they actually do?
Okay, get this. The researchers took a rainbow trout one that had been euthanized, so definitely not swimming on its own.
Right, dead fish.
A dead fish.
Ah.
And they placed it in a water flow channel just behind a D-shaped cylinder, and then they watched.
And what happened?
Something extraordinary. Even though it was, deceased, and importantly, it was placed outside the area right behind the cylinder where you might expect some suction.
Okay.
The fish started moving upstream against the current.
Wait, hold on. A dead fish moved against the flow by itself. I'm still trying to wrap my head around that. It just seems wrong.
It does seem wrong, but that's the discovery. The key is what the scientists called passive propulsion.
Passive propulsion. Okay.
Yeah. So the fish's body, because it's flexible, even though it wasn't actively moving, it started to resonate, kind of like wiggle in sync with the swirling water patterns coming off the cylinder.
You mean those little whirlpools you see in a stream behind a rock?
Exactly. Those are called Carmen vortices, forming a sort of street of swirls. The fish's body somehow extracted energy from those oncoming swirls.
So it wasn't being pushed by the water.
Yeah.
It was using the water's turbulence.
Precisely. It extracted enough energy to generate its own thrust, overcoming its own drag. It basically got a free ride upstream from the water flow itself.
A free ride. Wow. Okay, but how did they, prove it wasn't just some weird fluke, like a hidden current pulling it?
Good question. They used a technique called particle image velocimetry, PIV for short. It lets you see exactly how the water is moving everywhere.
Okay, like mapping the currents.
Exactly. And the PIV data confirmed it. There was absolutely zero upstream flow where the dead fish started moving. It wasn't being pulled. It was pure energy extraction from those vortices by the fish's passive body.
That is remarkable. So, okay, it's a fascinating fish story, but what does it mean beyond that? Is this just a biological curiosity?
Not at all. And that's maybe the most exciting part. They actually replicated the same effect using a non-biological object, a simple, passively mounted foil, like a thin wing.
Ah, so it's a physics principle, not just a fish thing.
Right. It suggests this could have real engineering applications. Think about designing maybe low-drag energy harvesting devices, things that could generate power just by sitting in a current, or even propel themselves.
Wow, like a self-powering sensor moving through water.
Potentially, yeah. It's this unsteady mechanism. An object interacting with a wavy or vertical flow can actually produce thrust and recover energy. It's pretty wild.
So if a dead fish can manage this passive trick, what about live fish? Do they just, turn off their muscles and coast upstream?
Well, it's a bit more sophisticated than that. Live trout do use the vortices, but they use an adapted behavior the researchers called the Carmen gait.
The Carmen gait, so they're actively doing something.
Yes, they actively synchronize their body movements, their swimming, with the rhythm of the vortex wake, which kind of begs the question, right? If you can move passively, why bother moving actively?
Yeah, what's the advantage of putting in the effort?
Energy savings, but with control. They did studies using electromyography, measuring muscle activity. And they found live trout using this Carmen gait significantly reduced their muscle activity, sometimes almost down to nothing for propulsion.
Really? So they are getting a mostly free ride?
Mostly, yes. But they're not just passively drifting. They use tiny muscle movements, maybe just in the front part of their body, or slight fin adjustments, primarily for stability and positioning, to stay in that sweet spot of the wake where they get the maximum energy boost without getting sucked too close to the object or drifting too far back.
Ah, I see. So it's like surfing the wake, but with active steering.
That's a great analogy. It's this clever balance, harnessing the passive energy available, but using minimal active control to stay perfectly positioned to keep harnessing it. It's not just passive, it's smart.
So This Ig Nobel-winning research, passive propulsion in vortex wakes,
Yeah.
it really does make you laugh at the idea of a dead fish swimming upstream, but then it makes you seriously rethink energy and movement.
Absolutely. It shows how even seemingly simple interactions in nature can hide these really ingenious ways of extracting energy.
It certainly challenges our assumptions. It makes you wonder, doesn't it? What other free rides, what other hidden energy sources are all around us, just waiting for us to understand or maybe even harness?
That's the big question, isn't it? There's likely so much more out there.
Well, that's all the time we have for this deep dive. Join us next time for another fascinating look at what the studies say. Make sure to subscribe and share this if you found it interesting.